Hi, and welcome back. We are on Unit 2. We made it to Unit 2. So the first thing we're doing in this unit is defining average and instantaneous rate of change at a point. We kind of already did that, so we're also going to look at how to find the instantaneous rate of change and how to create the tangent line and the definition of derivatives. That's what Unit 2 is all about, derivatives. First thing we're going to do is I have a graph here. This is the graph of y equals x squared minus 2x. So I covered this in my first video, Unit 1. To find the average rate of change between 2 points, for example, 3 and 0, right? If you found the average rate of change between these 2 points, or the average slope, it would look like this. And this is called a secant line. The equation is f of x2 minus f of x1 over x2 minus x1. This is the equation to find the average rate of change over a distance. So this line that it creates, this is called a secant line. It connects 2 points on the graph and gives you the average slope between them. Is called a secant line. We learned that. This is pre-calc. This is also my other video. But in my other video, we talked about the tangent line, which is if we wanted to find the slope at 3, right? It would look something like this green line that we have right here. It's the tangent line. It's a slope at the point of 3 exactly, and like where it's going, right? So how would we find this? I told you that you pick a number that's getting closer and closer and closer and closer and closer to 3, right? That's what we went over. But all last unit, we learned about limits. So now we could just use limits. So the equation to find the instantaneous rate of change is limit when h approaches 0 of f of x plus h minus f of x over h. It's similar to the average rate of change, but it's different because now we got this h and we got this limit and we got this h and we got this h. And what is h, right? All h is the distance between 2 points. So, for example, if you look at this original 0 and 3, right? If we're trying to find this average, we could use this equation, but h would be 3, right? Because it's 3 away. So the reason why the instantaneous rate of change works is because h is 0. You're looking at something that's like it's 0 far away, right? It's at 1 point. You're looking at the same point. And now that we know how to do limits, we could actually solve this and find what the tangent line is because we know how to solve limits algebraically. So if you look at this, and we look at this formula, and we look at this graph that we have, we could use this formula to find the slope at 3, exactly. If you tried to substitute it in, you would get something over 0, so that doesn't work, so we have to keep the h for now and solve it algebraically. The first thing we want to do is you're going to want to plug in x plus h and x into this equation. So we're looking at the slope. We're trying to find the instantaneous slope at 3. So x equals 3 here, right? So if x is 3, and this is our original function down here, right? 3 plus h, if we plug that in, our first term, x squared, if we're plugging in x plus h, and our x is 3, we're going to have 3 plus h squared minus our next term, 2x, 2, and we're plugging in 3 plus h minus f of x, which is just our y value at 3, which is just 3. Or we could plug 3 into this and get 9 minus 6 equals 3, right? Over h. So this is step 1. Now what we're going to want to do is we're going to simplify the top because we still can't plug our limit of 0 into this because it'll still be over 0. So we have to simplify out the top. So if we multiply out our first term, we get 9 plus 6h plus h squared minus, then we distribute this 2, we get 6 minus, it's a negative 2, so it's minus again, minus 2h, and then minus 3 at the end, all over h. And then this is algebra, we combine like terms, this negative 6 and this negative 3 cancel out with this 9, because it's 9 minus 9, so then you're left with h squared, and then 6h, negative 2h, plus 4h over h. We're so close, it's right there. We can factor out an h out of this top. We can get h times h plus 4 over h. And then these cancel out, and you're left with h plus 4. And now you can plug the limit of h approaching 0 in to h plus 4, and you just get 4. So the instantaneous rate of change at the point of 3 on this graph is 4. This is called definition of derivatives. I'll put up one more practice problem, But there's a way faster way to do it, and that's the way that you use throughout the whole curriculum. Like I got through the whole Calc AD class, the whole exam, never knowing what this formula was. I just knew the shortcut. So we're gonna learn the shortcut, but we're gonna learn this one more time in case it comes up on your test. We're gonna look at one more. Okay, so for another example, we're gonna look at what is the instantaneous rate of change of f of x when x equals 2. We have our f of x formula right here. So as a reminder, the formula is f of x plus h minus f of x over h when h is approaching 0. So I'll give you all a second to solve this. Go ahead, pause. I'll do a little 3, 2, 1. Okay, let's solve it. Let's go over it. Review the answer that you solved because I know you paused it and practiced it. So we're plugging in 2 here, right? Because where x is 2. So if we plug it in, our first term is 4, 2 plus h squared minus our second term, 6, 2 plus h, and then minus f of x. We plug 2 in, we get 4 times 4, we get 16, minus 12, we get 4, all over h. Okay, let's simplify this out. First thing, PEMDAS, you do the exponent. So you get 4 times 4 plus 4h plus h squared minus, we can multiply this out, 12 minus 6h minus 4 all over h. And now at the bottom we can multiply this out. We have 16 plus 16h plus 4h squared minus 12 minus 6h minus 4 all over h. So after you do this, this 12, this 4, negative 12, this negative 4, and the 16 are all going to cancel. Okay, and then this 16h and this negative 6h, this is going to cancel, and this is going to get the minus 6, right? So you have 4h squared plus 10h all over h. You can factor this. You have h, 4h plus 10 over h. These cancel. You add back the limit. When h is approaching 0, you have 4h plus 10. This h is 0, so that's gone, right? Because you plug it in, you have 10. Boom. Yeah, that's it. Hopefully y'all got that. Now you're going to learn the shortcut. Also, side note, the slope of any line at one point, the instantaneous rate of change, is called the derivative. That's what it is. The f of x plus h minus f of x over h when limit h is approaching 0. This formula here is the formula for a derivative. This is the definition of a derivative. So every time I say derivative, I'm talking about the instantaneous rate of change. Yeah. So the derivative of any function is normally written f of x, right? The derivative of any function is called f prime of x. The derivative is the slope at any point. So the derivative of any function f of x is f prime of x. This is just like knowledge you have to know before we can start talking about calculus. So if f of x is x squared, right? And I told you that we're going to find the instantaneous rate of change at x equals 3. You could set up the x plus h minus f of x over h limit h 0, right? And you can spend 20 minutes solving this and like be bored. Or we can learn this brand new concept that's going to save you so much time. It's called the power rule. So if f of x is x squared, f prime of x is 2x. Whoa, I know it's crazy. If f of x is x to the third, f prime of x, or the derivative, is 3x squared. So what is the pattern here? What's going on? How would you solve this? I'll do 2 more examples, see if you can figure it out. If f of x is x to the fourth, f prime of x is 4x to the third. If f of x is x to the fifth, f prime of x is 5x to the fourth. So surely y'all can see what's going on here. the power rule, you're taking the exponent, you're putting it in front of the x, and you're subtracting 1 from the exponent. So if this is 2, this is x to the power 1, right? You have x to the third here, you put the 3 in front, 3 minus 2 is 1. X to the fourth, you put the 4 in front, 4 minus 1 is 3. X to the fifth, you put the 5 in front, 5 minus 1 is 4, right? That's all you're doing. Any function, right? You could just do this. And then if you want to find the slope at a specific point, you just plug the number into your derivative function. So, for example, let's look at the equation f of x equals x to the power of 3. And we have to find the instantaneous rate of change when x equals, I don't know, 2. Actually, 4. Let's go when x equals 4. How do we do this? We could set up the big x plus h over h, whatever. Or we can see that, okay, bring the 3 down in front. F prime of x equals 3x squared, right? So f prime of 4, because we're plugging 4 in, is 3 times 4 squared, which is 3 times 16, which is 48. Yeah, so the instantaneous rate of change at 4 for this function is 48, and you don't have to set up the whole big thing. Yep.